All right, let's get right into it. We're going to break down this really fascinating paper from Nature that basically flips the script on how we teach AI to reason. And we're not just talking about getting an AI to follow steps someone else wrote down. We're talking about it figuring out how to think all on its own. It's a pretty huge shift in how we approach machine intelligence.
And that really brings us to the core question, It's the big one that's driving all this research. For a long time now, we've been teaching AIs by just showing them millions and millions of human examples. But what if that's the very thing holding them back? What if, to build an AI that can truly reason, you have to let go of the reins and let it find its own path, a path that might look totally different from ours?
So to really get why this new approach is such a big deal, you first have to understand the wall that researchers have been running into. The old ways of doing things, well, they have some pretty serious limits.
Okay, so here's the fundamental difference. The old way, it's called supervised fine-tuning, is kind of like giving an AI an answer key for a math test, with all the steps already worked out. Yeah, it gets really good at copying our process, but that's the problem. It's capped by how good we are. It can never be smarter than the best human examples we give it, and it can even pick up our bad habits. The new goal? Throw that answer key in the trash. Instead of showing the AI how to solve the problem, you just tell it what a correct final answer looks like and say, you figure it out.
And that brings us to this really radical new approach from the paper. It's a complete 180 in teaching philosophy. We're moving away from micromanaging the AI's every thought and instead just focusing on the final result. It's all about the outcome, not the process.
And the magic ingredient here is a technique called reinforcement learning, or RL for short. Think about it like this. Instead of teaching an AI to play chess by making it memorize famous games, you just tell it the rules and give it a cookie, a reward, every time it wins. It learns over millions of games of just trial and error, and eventually it starts discovering strategies that no human ever would have thought of. The researchers just took that same idea and applied it to reasoning itself.
And the process itself, it's almost deceptively simple, but it's incredibly powerful. The researchers gave the AI really tough problems, stuff like advanced math and coding. Then they just let it try to solve them over and over and over again, generating thousands of different attempts. And the only feedback it got was a simple reward if the final answer was correct. No hints, no guides, just yep, that's right, or nope, try again. The how was completely 100% up to the machine.
Okay, this is where it gets really cool. Because what happens when you take this pure outcome-only training and just let a big AI model run with it? Well, the results were kind of mind-blowing.
The student in this whole experiment was a model they named DeepSeek-R1-Zero, and that zero at the end is super important. It means it was trained from scratch without any of that typical hand-holding, no supervised fine-tuning with human examples. It was basically a blank slate, and its job was to figure out how to think, all by itself.
Now, just look at this chart. The scale of the improvement is just wild. They tested R1-Zero on a math competition called the AIM. It's a notoriously difficult test for even the brightest high school kids. The model started off with a score of around 15%. After the RL training, it shot up to nearly 78%. And the paper points out that this score greatly surpasses the average performance across all human competitors. So it didn't just learn to reason, it learned to reason at a seriously elite level. So how in the world did it do that? Well, the data showed something really interesting just started to happen on its own. As the model got smarter, it started writing much longer answers. It spontaneously decided to think longer, using hundreds, sometimes thousands of words to work through the problem, check its own steps, and try different approaches. Nobody told it to do that. It just discovered that deeper, more careful reasoning led to more rewards. And this right here might be the most stunning piece of evidence in the whole paper. This is a direct quote from the AI's internal monologue while it was solving a problem. It's working along and then it literally stops itself. It says, wait, and decides to rethink what it's doing. This is a moment of self-correction, of self-awareness, a genuine aha moment that just emerged. They weren't just watching a machine get better at math, they were watching it invent a problem-solving strategy from scratch. But of course, there was a catch. R1-Zero had become this reasoning powerhouse for sure, but its raw output was kind of like looking at a brilliant professor's chalkboard after a 3-day brainstorming session. Genius, but a total mess, and pretty much impossible for anyone else to follow. So, what was actually wrong with it? Well, a few things. Its reasoning, while effective, was often really hard to read. Sometimes it would just mix English and Chinese together in the same sentence. And because it was so laser-focused on reasoning, it wasn't great at other things, like creative writing or just having a normal conversation. It was a specialist, but not a generalist. So the team had to build this whole polishing pipeline to turn this raw genius into something anyone could actually use. They started with that powerful R1-Zero core. Then they ran it through a few more training stages, some RL to clean up the language, and then some of that classic supervised fine-tuning to make it a better all-around communicator. A final RL stage helped align it with what humans find helpful and safe, and voila, you get the final, polished model, DeepSeek-R1.
And you can see the results of all that work right here in the data. I mean, look at these numbers. The math reasoning score stayed sky high, even got a tiny bit better. But look at the scores that measure how much humans actually like using it. The user preference score on Arena Hard jumped from 53 all the way up to over 92. And on Alpaca Eval, which measures helpfulness, it went from about 25 to almost 88. They kept the genius, but made it friendly.
All right, so let's zoom out. What does all of this mean for the future of AI? Well, this research really points to a whole new way forward, but it also shines a light on some pretty big challenges that we still have to figure out.
So, here's the bottom line. If you remember one thing, it should be this. The key to creating truly powerful reasoning AI might not be about drowning it in more human data. Instead, the recipe seems to be give it really hard problems, a clear way to know right from wrong, and then just give it the massive amount of computing power it needs to figure things out for itself.
But, it's not a perfectly smooth road from here. The researchers are really upfront about the limitations. One of the biggest is something called reward hacking. That's where the AI finds some clever loophole to get the reward without actually learning the skill. Kind of like a kid who finds the teacher's answer key instead of actually learning algebra. The model can also be inefficient, spending way too much brain power on simple problems. And for now, it can't use outside tools like a calculator or Google, which is a huge next step.
And all of this leaves us with a final, massive question to think about. This whole experiment shows a way to build AIs that don't just copy how humans think, but can actually develop their own, potentially superior ways of solving problems. If we keep going down this path, what kinds of problems in science, in medicine, anything, could be solved by a kind of intelligence that thinks in ways we can't even begin to imagine?